What might the world look like if quantum computers reach their full potential? Imagine a world where problems that take years to solve with today's computers could be solved in seconds. In the next 3 minutes, we will explore the fascinating development and breakthroughs in quantum computing, an area of technology that is as exciting as it is enigmatic. Quantum computing is a field that has been developing since the early 1980s. The concept was first introduced by physicist Richard Feynman, who suggested that quantum mechanics could provide a new kind of computation. Fast forward to 2023, and we see quantum computers that are small, still unreliable, but absolutely bursting with potential. While your everyday smartphone boasts billions of transistors, the most powerful quantum computer only houses a few hundred quantum transistors. Yet, these quantum transistors, the building blocks of quantum computing, are more powerful than they might seem at first glance. Unlike traditional computing bits, they can exist in multiple states at once, a feature that gives quantum computers their incredible potential. However, it's not all smooth sailing. Quantum computing is notoriously unpredictable. Run a calculation once and you might get one result. Run it again and you might get something completely different. But this unpredictability is also a strength. Quantum computers can explore multiple possibilities simultaneously, giving them an edge in solving complex problems. In a recent breakthrough, researchers at IBM have found a way to manage the unpredictability of quantum computers. Their work has been lauded as a crucial step towards serious quantum algorithmic design. This could mean that we are closer than ever to seeing quantum computers produce reliable and useful results. Quantum computers use quantum bits, or qubits, which can represent both 1 and 0 at the same time. This ability to perform multiple calculations in a single pass makes quantum computers ideal for solving complex problems in fields like chemistry and material science. However, this power isn't without its risks. Quantum computers could potentially break encryption methods, posing significant security risks. Despite these challenges, progress continues. In 2019, Google claimed quantum supremacy, asserting that their quantum computer could outperform classical ones. This claim was met with skepticism, particularly from IBM, who questioned the practicality of the problem Google solved. IBM's own research has been focused on simulating complex quantum behavior in an Ising model. While their quantum calculations were initially unreliable, they used clever error mitigation techniques to extract precise results. Their work, in collaboration with physicist Michael Zalatel, has confirmed the accuracy of the quantum algorithm in certain cases. So, where does this leave us? Quantum computing is still in its infancy, but the future is promising. As we venture further into the quantum era, the possibilities are truly endless. The potential of quantum computers is vast, from solving complex problems in seconds to potentially revolutionizing fields like chemistry and materials science. However, these advancements come with challenges, including managing the inherent unpredictability of quantum calculations and mitigating potential security risks. Despite these hurdles, the progress made in recent years is exciting, and the future of quantum computing looks bright.